So hello everyone. In this video, we will be looking at another sorting algorithm which is called as selection sort. It's a quite easy algorithm. So let's just first, as usual, go through our dry run, okay, or understand the logic, and then at the end we will code it. Okay. So what is the basic idea behind selection sort? So the basic idea behind selection sort is to find the lowest element, okay, and put it in the beginning. Okay, so if you remember the previous bubble sort algorithm video, so the logic here or the idea here is basically exactly opposite to what we were normally doing in a bubble sort video. Okay, what we were normally doing in a bubble sort video. Okay, so in this we are first finding the lowest element and putting it in the beginning. Okay, now remember, as far as this selection sort is concerned, we will be playing with three variables. Okay, we will be playing with three variables. If you know how to operate on these three variables, or how these three variables are working with each other, okay, you can easily remember the selection sort algorithm. And these three variables are I, J, and M. Okay, these three variables are I, J, and M. Okay, so step one step one is I will move from 0 to arr dot length minus 1. Okay, then step 2 is j will move from I plus 1. Okay, remember, j will move from I plus 1, so j will always be basically one position ahead of I. Okay, I plus 1 to arr dot length minus 1. Okay, and step 3 is m will be initialized. Okay, initialized to I at the start of each iteration. Okay, at the start of each iteration. Okay, now let's see what is happening exactly. Okay, so I will start from here. Okay, and j will start from here. Okay, correct. And m will start from m will be initialized to I at the start of each iteration. Now what we will do is we will basically compare value at m with value at j. Okay, so if you remember, we have solved a very simple problem in our previous videos, and the problem was finding the smallest element in an array. So if you remember, in the problem for finding the smallest element in an array, we used to not do nothing but to compare, to take one element as a reference and compare it with all other elements. And if we were finding any element which was smaller than current assumed smallest element, then we used to just update the index for smallest element. Okay, so if arr of m is greater than arr of j. Okay, so m is basically current minimum. Okay, position of current minimum. Okay, and if we are finding that value at j, okay, value at j is smaller than our current assumed minimum, is smaller than our current assumed minimum, then simply do nothing but m is equal to j. Just update the index for smallest element. So we compare if 4 is less than 5, okay, or 5 is greater than 4. So yes, it is. So uh, this will be executed and m will be now at this position. Okay, now j plus plus. Okay, now again compare if it is less than current minimum. Yeah, value at j is less than current minimum. So yes, it is. Update. Okay, again j plus plus. Then see if it is again less than. So it is not. So m will remain here only. Okay, then again increment j. Again compare. Okay, and in this way one iteration for j will be complete. So inner loop iteration has completed. Okay, and now what will happen? Now once we exit from inner loop, we will swap these elements. Okay, swap arr of m with arr of I. Swap arr of m with arr of I. Okay, step 5. Okay, swap arr of m with arr of I in the outer loop. Most important thing. Okay, in the outer loop. Okay, so basically in the inner loop we are just traversing with variable j, and we are finding the finding the minimum element and storing the index of minimum element in m. Okay, so after first iteration, 5 will come here and 1 will come here. Okay, then I plus plus j will start from I plus 1, and again m will be initialized to I. Okay, so this was the end of first iteration. Okay, so and this was the end of first iteration. Now again we will keep going on and do the same thing. Okay, so again compare j with m. Okay, so value at j is greater than value at m, so no need to swap. Then compare. So yes, now this time value of j is less than value at m, so update m. Okay, update m. So m will now become this and j plus plus. Okay, now again compare value at j with value at m. Okay, so we find that again it is less than current value at m, so update m. Okay, now iteration for j has finished, and we will come in the outer loop. Okay, so in the again I am stressing in the inner loop. Okay, on in inner loop. Okay, in inner loop we are just comparing and finding the index of minimum element. Okay, finding the index of minimum element. Okay, so now traversing of j has been completed, and now what we will do is now we will come in the outer loop and we will swap arr of m with arr of I. Okay, so now 4 will be swapped with 2. Okay, and then I plus plus j is equal to I plus 1. Okay, and m will be initialized to I. Okay, now compare if value at j is less than value at m. So yes, it is. So update m. M will come here. Okay, now again j plus plus. Now we again compare value at j, is it less than value at m? So no, so no need to update the value of m. So traversing of j has finished. Now we will come in outer loop. Now we will come in outer loop, and we will swap value at I with value at m. So basically 3 will be swapped with 5, and I plus plus. Okay, m will be initialized to I, and j is equal to I plus 1. Okay, and then what? Again we will compare if value at j, last iteration. Okay, now this is the last iteration. J, value at j with value at m. So yes, it is less. Value at j is less than value at m. So update m. Okay, traversing of j has been completed. Now swap value at I with value at m. So 5 will be swapped with 4. Okay, so I hope now you have understood the complete logic. So all we need to do is to find the lowest element and put it in the beginning. We are requiring two for loops, which are basically nested loops. So the time complexity will be n square. Time complexity will be n square. All you need to do is to just remember how these three variables I, j, and m are working. So if I need to tell you again, I will move from zero first index to last index. J will always move from I plus 1 to last. M will be initialized to I. Okay, at the start of each iteration, M will be initialized to I. Okay, ठीक है. This initialization done in outer loop. ठीक है, this initialization done in outer loop. Okay, in the inner loop, we are just comparing the value if the value at j is less than value at m, and if so, we are updating the value for minimum index, the value for minimum index. Okay, and then only this much is done in inner loop, and this part m is initializing m is also done in outer loop. And then once we come out from inner loop, again in the outer loop we will swap value at m, that is minimum index, with value at I. Okay, so it is as simple as that. I hope the dry run and the intuition and idea behind the algorithm was clear. Okay, so now let's just code it. So public class main, as usual, because the name of file is main.java. Public static void main, and let's just declare an array 4 1 3 2. Okay, perfect. um, uh, let's just first print our array before sorting. So array before sorting, and this would be directly done by writing a for each loop. X plus, okay, and yes, okay, and then call selection sort, call selection sort algorithm, and pass our array as a input parameter to it. And then once sorting is done, we will just print the array after sorting. Okay, array after sorting, and let's just return the modified array, update the return the modified array from this function, and update it to our pre-existing one. Okay, perfect. Okay, so static, because we will be returning an array, so the return type would be an integer type array, and the parameter passed to our function is an array. Okay, perfect. Now for int I is equal to 0, I less than arr dot length, I plus, sorry, I plus plus. Okay, now in the outer loop, as I have mentioned, we will initialize a variable m to I. Okay, now in the inner loop, we will play with variable j, and as I have mentioned, it will always start from I plus 1 to j less than arr dot length and j plus plus. Okay, and inside this we are doing just one simple thing. If arr of m is greater than arr of j, okay, then simply m is equal to j. Only this much we are doing in our inner loop. Now we come out of this inner loop, and what we will do, we will swap what, swap arr of I with arr of m. Okay, so int temp is equal to arr of I, arr of I is equal to arr of m, arr of m is equal to temp. Correct. And at the end we will just return our modified array, which is nothing but a sorted array. Okay, now let's just try to run it. I hope we will not get any errors. Let's see. Perfect. So okay, let's just try to run it again. Okay, perfect. So initially our array was 5 4 1 3 2, and after sorting it has become 1 2 3 4 5. So I hope the dry run and the logic is pretty clear. So remember, we just need to play with three variables. Okay, so and those three variables are I, j and m. If you know how to play with these three variables, rest is very easy. Okay, and the basic idea behind selection sort is to find the lowest element and put it in the beginning. Okay, so I will start from 0 to last g, then m will be initialized to I at the start of every iteration. So okay, so this is a very important step. Initialize m to I. J will always start from I plus 1 to last. Okay, then what we will do, we will just compare value at m with value at j. So basically m is nothing but our current assumed minimum. Okay, our current assumed minimum. Okay, and if the value at j is less than value at m, then we will update the index of m. Okay, and then at the end we will just do a swapping. So basically this inner loop helps us in finding out the index of current lowest element. This inner loop basically helps us in finding out the index of current lowest element. And once we have known the current lowest element, okay, all we need to do is a swapping. So I hope this code was clear. Okay, and you can take a screenshot if you want of this following code. I think the code and dry run was very easy, and so all you need to remember is to how to play with these three variables and how I, j, and m are initialized. What is happening in the outer loop, what is happening in the inner loop, and again at the end what is happening in terms of swapping in the outer loop. So this is all for this video. I hope the algorithm for selection sort is crystal clear. If not, you can anytime rewatch the whole video. So thank you everyone for watching till end. If you think I have made any significant contribution in your logic building, please do consider liking and subscribing to my channel. All because my only motive is to contribute to your logic building. So thank you everyone and see you in the next one.